Hi everyone. In this video we are going to cover introduction to the vectors. First, when we look at physical quantities in science and more particularly in physics, we divide them into these two categories, which is called as the vectors and scalars. So what is this vectors and scalars? Say for example, I look at an object of mass 2 kg and I add another mass of 3 kg to this, then the total mass will be equal to 5 kg. Now from this 5 kg, if I remove some 1 kg, then the remaining mass will be simply equal to 4 kg. I'll come back to why I'm explaining this approach in terms of the scalar quantities. If I want to mention the mass of a particular object, if I say that the mass is 2 kg or mass is 3 kg, whatever the mass might be, that information alone will be sufficient to completely describe these quantities, like example mass, time, all these quantities, right, which we can explain by just giving the value. They are called as what? Scalars. And what is the speciality of the scalars? Scalars, they will be following the simple algebraic addition subtraction principles. On the other hand, let us say for example, I need to say that I am applying a force of 4 newtons on a particular object. Now just by giving the value of the force, the information will not be complete. I also need to mention in what direction I am applying this force. Am I applying it in the east, or am I applying in the west, or what direction I am applying this particular force? So when we look at these vector quantities, definitely they will be having the magnitude and direction. So the value of the force can be also called as what? The magnitude. So they will have the magnitude and the direction part of it. Not only that, when we look at the way they add, okay, so we will come to know about the details of addition in a little while. But let us say for example, on the block I am applying a force 5 newtons here and another force 1 newton. If you see what is the total force in this case, it will become 6 newtons. Whereas I apply the same 5 newtons like this and I apply the 1 newton in some other direction, which is happening to be here the opposite direction, then the total force acting on the body will be simply equal to what? 4 newtons. So the way they are adding is not only depending upon the values, but also it depends upon the direction. So this particular principle of addition is actually called as what? Vector law of addition. It is called as vector law of addition. So physical quantities that have the magnitude part, direction, and also satisfy this vector law of addition, where what is the basic idea of the vector law of addition? When we are adding the quantities, the resultant or the total value not only depends upon the magnitudes, but also depends upon the angle or the orientation between them. Such quantities are called as vectors. Now why we are emphasizing so much on this vector law of addition is, we do have quantities like electric current. Say for example, I have a combination of 3 wires like this, where a current of 1 ampere is coming here and current of 2 amperes. The total current that goes out will be 3 amperes. Now we know that electric current has got magnitude, the value is there. It has also got the direction. When we talk about the conventional current, we mention a particular direction for that. But if you look at it, the way the electric current is adding, it would not depend upon the orientation. Say for example, I will change the orientation of the wires like this. I will make one wire like this, other wire like this. Still 1 ampere is coming here, 2 ampere is coming. The total current in the other wire that will go out will be again 3 amperes only. It will not depend upon the orientation. So electric current has got magnitude and direction, but it does not satisfy the vector law of addition. So hence we don't call it as a vector, we call it as a scalar. So we will get into the details of what is a vector and what is a scalar, but broadly this is what is in terms of the differentiation between the physical quantities as scalars and vectors. And we have many examples, like mostly if you look at the physical quantities that we are going to see, a majority of them, like whether it is the force or the acceleration or so many of them, right, they're all what? Vectors. So we'll just start in terms of the basics of it. So scalars are those physical quantities that have only the magnitude and they don't have any direction associated. Examples of the scalars are, I mean, so many things that we already know of: mass, time, speed. I mean, all these quantities, right? They can be completely described just because of their magnitude. And one more thing, as I mentioned earlier, they will be adding as per the simple rules of the algebraic addition. Like I say, for example, if I cover some 10-meter distance and then I again cover another 5-meter distance, the total distance covered will be equal to 15 meters. The way they add will be as per the simple algebraic addition rules. Now, talking about the vectors, as we have, I mean, just now spoken, they have both the magnitude part and direction. And most important thing is they also satisfy this vector law of addition. We'll try to understand the vector law of addition by using this concept of triangle law of addition. There is one more explanation for that, which is called as the parallelogram law of addition. But basically the vector law of addition core idea is when the quantities are added, the total value or the resultant not only depends upon the values of the vectors, but also depends upon the orientation between them. Examples of vector quantities: displacement, velocity, acceleration, momentum, force. I mean, there are so many of them that we are going to be covering in the entire +1 +2 or the JEE and NEET syllabus. Now the thing about vectors is you cannot add them just by following the algebraic addition rules. What it basically means is, if I say that on an object I am applying two forces, 1 Newton and 2 Newtons, we cannot jump and say that the total force acting on the body is 3 Newtons. We have to understand what is the orientation or the angle between them. Only then we will be able to comment on the resultant value or the total value of the force. So this is one of the very important thing that we need to be keeping in mind in terms of the vectors. Now we understand what is a vector basically. Let us look at how do we go about representing them. So there are basically two broad ways of representation of vector. One is this algebraic representation. Say for example, I want to represent acceleration, I'll put A bar. I want to represent force, I'll put F bar. I want to represent linear momentum. The symbol for the linear momentum is small p. So a vector can be used by simple algebraic representation. Only thing is we'll be keeping a bar above it. Okay, so that is what is the representation of the vector. Whereas if I am talking about the mass will be simply m. Now let us not think that just because I am keeping a bar above, that makes a physical quantity a vector. So I have a mass, just because I keep a bar above it, the mass cannot become a vector. So already there are vectors, and to represent them only we use this notation. This is the first representation, which is the alphabetical representation. The second representation is geometrical representation. Every vector can be represented in the space by a line segment. Now here there are two important things. One will be the length of the line segment, and second is the arrow. The length of the line segment, it will be indicating the magnitude of the vector. It will be a representation of the magnitude, which means basically, like say I represent a vector like this and another vector. The orientations might be different, but look at the length here and look at the length here. You can say that if I have to give them some names, I can say that the vector B bar has got a higher magnitude than the vector A bar. Okay. Now the arrow importance is, arrow will be indicating the direction of the particular vector. Say for example, here I can say that the V bar is clearly towards the right side. So the importance of the arrow is to indicate the direction part. Now one of the very important properties of the vector is translation of vector in a space. What it basically means is, say for example, I ask somebody to represent a vector of 2 units magnitude towards the east. So what we'll do, we'll just mark a point. From there we will just draw a line of 2 units, and this is towards the east, assuming. Someone else can also draw the same vector here. Someone else can also draw the same vector here, which means the relation between all these representations is what? If you take any of them, I mean, you have to put on with the representation, because the way it is appearing is as if they are all not of same length, but assume that they are all of the same length. If you can take one vector and simply move this in the space, I bring it here, that is what this representation. I bring it here, that is what is this representation. I bring it here, that is what is this representation. I bring it here, that is what is this representation. So translation of vector in space without changing the direction. So why, we should not change the direction is, the moment we change the direction, that makes the vector to be a different vector. Why? Because a vector is also associated with the direction part. So translation of vector in space will not change the vector value. The other property is multiplying a vector with a constant. Let us say, for example, we have a vector a bar and we are trying to multiply the vector with a constant k. Remember guys, k can be positive, k can be negative, k can even be 0. If you multiply the vector with a constant k, then what this represents is, if k is positive, then the resultant vector will be in the same direction as the initial vector a bar, and if k is negative means the resultant will be in the opposite direction, which basically means if I have a bar like this, k can have any value. I'm just saying if k is positive, let us say k value is equal to 2, then 2a bar will be in the same direction as a bar, but length will be just twice. Whereas if I take minus 2a bar, it will be also 2 times. In terms of the length, it will be also 2 times, but direction will be just exactly opposite. So any vector, if it is multiplied by a constant k, the resultant vector will be modulus of k times. Why we are putting the modulus is because k can be sometimes positive, k can be sometimes negative. The resultant vector will be modulus of k times longer than the vector a bar, and the direction part of it will depend upon the k sign. If k is positive means the resultant will be in the same direction as the a bar. K is negative means the resultant will be exactly in the opposite direction. Now from here we can also get to the concept of what is a negative vector. What is a negative vector? If I simply have a vector a bar and I put, so there is a vector a bar and I put minus a bar. So minus a bar will be exactly having the same magnitude but opposite direction. So you can see in the representation over here, this is a bar and this will be what? Minus a bar. Unit vector. So whenever we talk about vectors in space, we know that there is a direction part associated. So direction is generally given in terms of what we call as unit vector. Let us say there is a vector a bar. The unit vector in the direction will be given by what we call as a cap. The representation is like this. We'll have an a and then put a cap over it. So what is this unit vector? So say for example, there is this a bar, and I'm saying there is a unit vector in the same direction, which is a cap. So you have to take a cap and multiply this how many times? The magnitude of a, to get the final vector a bar, which essentially means if I take a, which is the magnitude of that vector a bar, and multiply this with that a cap. A cap is what? Unit vector along the same direction. That multiplication value will simply give us what? A bar. The multiplication value will simply give us a bar. So this is what is the unit vector concept. So unit vectors are generally used to represent the direction. So if I want to represent a cap means that will be simply equal to a bar by a. Simply equal to what? A bar by a. So any vector divided by the magnitude, it will give us unit vector along that particular direction. Now since we have these x-axis, y-axis, z-axis as important axis, we represent unit vectors along those directions as I cap, j cap and k cap. And these three combination is also called as the orthogonal triad, because they will be perpendicular to each other. So in terms of looking at it, if we have I cap along the positive x-axis, then j cap will be along the positive y-axis, k cap will be along the positive z-axis. These are the unit vectors along the positive x, positive y and positive z. If I want to represent what is the unit vector along the negative x-axis, that will be simply minus I cap. What is the unit vector along the negative y-axis? It will be simply minus j cap. What is the unit vector along the negative z-axis? It will be simply minus k cap. So this is about the unit vectors along the x-axis, y-axis and z-axis. Now we also have some more nomenclature that is generally used in terms of the vectors. So one is this co-initial vectors or concurrent vectors. Basically they will have the same starting point. You can see all these vectors, 4 vectors given here, they will have the same initial point. And coterminous vectors basically means they have the same common terminal point. You can see all these three vectors given over here, a bar, b bar and c bar, they are having the same common ending point. So we call them as coterminal vectors. So we have concurrent vectors or co-initial vectors and coterminous vectors which have the same ending point. Some more definitions about the vectors. Collinear vectors. So collinear vectors means the vectors that are acting along the same line. But keep one thing in mind, they can be in the same direction or they can be in the opposite direction. Like say for example, I have a vector a bar and another vector b bar. Here both of them happen to be in the same direction. I have vector a bar and I have another vector c bar, but they both are exactly in the opposite direction, but we can call them as collinear vectors. Parallel vectors means two collinear vectors which are acting along the same direction. Like in the previous case, as I mentioned, a bar and b bar will become what? Parallel vectors. And anti-parallel means two collinear vectors which are acting in the opposite direction. Like in this case, a bar and c bar will be the anti-parallel vectors. Coplanar vectors, because vectors can be in a plane, vector can be in a space. If a given number of vectors are lying in the same plane, like in this case, you can see clearly f1 bar, f2 bar, f3 bar and f4 bar, all the forces, they are lying in the same plane. We call them as coplanar vectors. Non-planar or non-coplanar vectors means the vectors which are lying in the space, which means we will not be able to find a common plane. These are called as what? Non-coplanar vectors. Equal vectors. So when we say the two vectors are equal, when they have same direction and also have same magnitude. Now we can see all the vectors that are drawn over here, they have the same magnitude as well as they are having the same orientation. So they are called as what? Equal vectors. Now this is one of the very important property of the vectors, which is the angle between the vectors. Now why do we need angle is, we have said when we talk about the vector law of addition, the orientation between the vectors is important. So what do you mean by orientation? How do we measure the orientation? Is by using the angle between the two vectors. To measure the angle between two vectors, let us say in this particular diagram, I have two vectors a bar and b bar. They have to be first represented as co-initial vectors. If they are not, we have to translate them and arrange them as co-initial. If you arrange them as co-initial, then you can clearly see here you are forming two angles, alpha and beta. And the angle between the two vectors a bar and b bar, this is the general representation. We'll keep them within the bracket. If I say it is theta, this theta will be taken as the smaller of alpha comma beta. Generally, if alpha is equal to, say for example 90, beta will be equal to 270, so that the total value will be always 360. So in this case, we will take alpha as the angle between the vectors. If alpha is equal to say 179, then beta will be equal to 181 degrees. So in this case, we will take alpha as the angle between the vectors. If alpha is equal to 180, in that case beta also will be equal to 180. In this case, we can take any of them. If alpha is equal to 181 degrees, then beta will become 179. In this case, we will take beta as the angle between the vectors, which means if the two vectors are parallel, then the angle between them will be 0. So the angle between any two vectors will start from 0 and it can go up to the maximum of 180 degrees or pi. In terms of degrees, it is 180 degrees, and in terms of radians, it will be pi. This is what is the angle between the vectors. Now to make us understand this angle between the vectors in a little bit more broader manner, let us say for example, I have a vector a bar like this and another vector b bar, and I say that this angle is 110. The question is, what is the angle between the two vectors? Here you can see a bar and b bar are not arranged as co-initial. We must first make them as what? Co-initial. We can't say 110 is the angle between the two vectors. So let us keep b bar as it is, and a bar alone I am translating it and bringing it over here, because already we have a property of the vector, translation will not change the value of the vector. Now we can see a bar and b bar, both of them are arranged as co-initial. This is 110 means by the property of angle on a line, this will be equal to 70. So now you can see here between a bar and b bar, what will be the angle? 70 degrees. Same way, if I have two vectors like this is the one vector, this is the other vector, this is a bar and this is b bar. The angle over here is, say for example 60. I cannot straight away jump and say that the angle between them is 60. Why? Because here the two vectors are not co-initial. they are in fact coterminous. How we will be doing is, we will translate the A vector forward and also we will translate the B vector forward. Once we translate them forward, now we can see they both have become co-initial. Now this is our A bar and this is our B bar. Here also you will be able to see that this is 60, means interestingly this also becomes 60 because of the vertically opposite angle property. So here I can say that yes, the angle between A bar and B bar is equal to what? 60. So when you want to represent angle between two vectors, we must first arrange them as co-initial vectors and then only we can talk about the angle between the vectors. Then another important property is the zero vector or null vector. A vector having zero magnitude is called as zero vector or null vector. The zero vector is supposed to have arbitrary direction, because when the magnitude itself is zero, there is no description for the direction of the zero vector. Position vector. Position vector is basically, if you have a point in a space, like say in this particular diagram, there is point A and there is point also B. This point A and point B. The vector that connects origin to the particular point is basically called as the position vector. In this case, OA bar represents what? The position vector of the particle A or the location A, and OB bar represents the position vector of the point B. From the position vector, we can also talk about one more concept called as displacement vector. Displacement vector basically means, if I start from one point and go to another point, the line joining the initial point and final point with an arrow pointing from the initial point to final point, this is what will be the displacement vector. Let us say in this diagram as it is shown, I move from A to B. I move from A to B, which means that AB bar will become the displacement vector. AB bar will become the displacement vector. So the displacement vector is actually the vector that is joining the initial point to the final point.